Hey guys, today I want to talk to you guys about calculations with significant figures. So, significant figures, as you guys have read in your textbook, are the way that we as scientists report how precise a given measurement is. We use lots of tools to measure in the sciences. So, we need a way to report how precise that tool was and how great of a measurement it was. So here is our first instrument that we're going to take a look at. So we're just going to quickly review how to read a digital instrument, and then we'll jump into how to recognize significant figures. So what we see here is this scale is measuring, let's say, a blue blob. This blue blob, when we put it onto this digital scale, reads out as 10.5 grams. So this scale gives me three significant figures: the 1, the 0, and the 5. So three significant figures here. What I'm going to show you now is another scale. So this scale is measuring the exact same blue blob, but when I put it on this scale, we see we get a lot more digits out of that. We get the 1, the 0, the 4, the 9, the 7, and the 7. So this scale gives us 6 significant figures. If I had to choose between these two instruments to measure my blue blob, I would choose the scale over here on the right because it gives me more significant figures. It gets me closer to the actual value of that blue blob. As scientists, we report our numbers in many, many different ways. So when you're reading a report or you're reading some sort of journal article, you want to be able to identify how good was that instrument that the scientist used? How close did it get to the actual value? So what we're going to talk about now is how we can read a number and identify how many significant figures or how many significant digits are in that number. So here's just quickly a list of rules that we're going to go over. All non-zero digits are significant. So zeros are when things start to get a little bit tricky. All non-zeros are significant. So if I read a number that looks like this, so let's say 1,256 miles. Well, none of those digits are a 0, which means all 4 of those are significant. So whatever instrument I use to measure that, I got 4 significant digits. And I like to abbreviate sig figs with just an SF. So this number has 4 sig figs. The next one, any interior zeros are significant. So if we find a 0 smack in the middle of a number, that 0 is then a significant number. So let's say we read a temperature of 103.5 degrees Fahrenheit. Okay. So looking at that number, I see a 0, so sometimes those can be tricky, but I see that the 0 is smack in the middle of the number. So how many significant digits are in this number? There's also 4. The 1, the 0, the 3, and the 5. So again, 4 sig figs. Next, any zeros after the decimal, after a number, are significant. Any zeros after a decimal, also after a number. So an example of that would be something like 3.0 centimeters. So what we see here is that we have a 0 after the decimal, after another number. So whatever instrument it is that I used gave me that 0 value. So this happened to fall right smack on that 0. It's significant. The instrument told me that it fell on that 0. So that's why we went ahead and put it down. The silly way that I have people remember this is that scientists are lazy. Hey, we as chemists use symbols for everything. We can't be bothered to actually write real words out. So if I, as a lazy chemist, bothered to put a decimal, and then I bothered to put 1 0 or 2 zeros or 3 zeros after it, I did that for a reason. I did it because the instrument gave me those values. They are significant. So that's kind of a silly way that I remember this one. So the first three are about things that are significant. The last two are about things that are not significant. Any leading zeros are not significant. So a leading zero would be anything that you see a zero first. You don't see any other digit. A zero is the first thing that you see. So an example of this would be something like 0.00001, we'll say inches. Okay. So the first 5 zeros that I put down are all leading zeros. They're simply placeholders. They're telling us about the magnitude of this number. So they are not significant. The only two values that are significant in this number are the 1 and the 2. So there's 2 sig figs in this number. The best way to clear up any leading zeros is to put it into scientific notation. So if I was to put this number into scientific notation, I move the decimal over until I get a number between 1 and 10. So I get 1.2 times 10. Then I tell the viewer how many places I moved it. 1, 2, 3, 4, 5 places. And it was a number that was less than 1, so that's going to be a negative 5. Now, looking at scientific notation, we see very clearly that the only digits that have any meaning are this 1 and this 2, so 2 significant figures. Lastly, we have zeros at the end without a decimal. So these are tricky, and they should be avoided with scientific notation. So I will avoid asking you questions about these. So a number like 500. Okay. So are there 3 significant figures and it landed right on that 0? Is there only 1 significant figure and the other 2 zeros are placeholders? We don't really know. You'd have to know more about the instrument. So I will avoid questions like this. 500, how many sig figs? Well, you don't know. You don't know. You can't figure that out. If you do have to report a number like 500, you will know how many sig figs are there. And the best way to report those is to use scientific notation. So put that number into scientific notation and only add the zeros that are significant in that. So that's how we determine which digits are significant. And this is a really, really important skill because as scientists, we don't just look at numbers and report numbers. As scientists, we like to math with numbers. The last thing that I want to talk about is calculations with these significant digits, so calculations with our numbers. We're going to talk about 2 different categories. We're going to talk about multiplication division, so that's one category. And we're going to talk about addition and subtraction. That's a completely different category. So let's start first with multiplication and division. When we are multiplying or dividing numbers together, we are limited by what I call the weakest link. The weakest link is the number that has the fewest or the least significant figures or significant digits. So if we look at these 3 numbers here on the slide, so let's say we're doing volume, for example. And we're multiplying 5.02 times 89.665 times 0.10. Our calculators, when we type those three numbers in, our not so smart calculators don't consider significant figures. So they just spit out a number and they don't even consider what instrument was used to find those numbers. So we as scientists have to do that thinking. Looking at the three numbers that we threw into the calculator, the one with the least number of significant digits, or the weakest link, is this guy right here. So he has two significant figures. So when I report this number right here, I can only report two digits, two significant digits. So when I actually report this number onto a piece of paper, I can only write down the 4 and the 5. I'm limited by two sig figs. I'm limited by the instrument that was the worst or gave us the least number of sig figs. Okay. So rounding is usually the next thing that comes up. I'm not going to split hairs on rounding. Okay. General rule of thumb is greater than 5. So the next digit is greater than 5. You would round up. If the next digit is equal to or less than 5, you would just leave it alone. So I'm not going to split hairs over rounding, but that's the general rule of thumb. Here's another example using division. So again, we are taking 5.892 divided by 6.10. Not so smart calculator spits out a ton of digits. This one has 4, this one has 3, so we're limited to 3 significant figures. So when I report this answer, I have to cut it off. So I can only keep the 9, the 6, and the 5, or this person noticed the next number was 9, so they rounded up. So 1, 2, 3 sig figs. That's what I'm going to be looking for. All right, so completely different thought process here. We're going to talk about addition and subtraction. With addition and subtraction, we are actually going to be counting decimal places. Counting decimal places, not significant digits, decimal places. The best thing to do as you're getting proficient at this skill is to do exactly what I did here on the screen and stack your numbers one on top of the other, okay? So what we see is we see 4.8 minus 3.965. So again, we throw that into a calculator. Not so smart calculator spits out all of these digits. In addition and subtraction, we're limited by the number with the least decimal places. So here we see the 4.8 cuts off at the 10th place. So when I cut my answer off, I will cut it off also at the 10th place. So all I can report is 0.8. Stacking the numbers on top of each other like this is helpful because you can draw a line behind that decimal place. Now we can keep everything to the left and we simply throw away everything to the right. So it gives us a good visual of where we cut this number off. So here's another example. I want you guys to pause the video and see if you can answer what we would report. So we threw these three numbers into the calculator. This is the number that our not so smart calculator spit out. What would you actually report? So pause, figure it out, and then hit play. So drawing a line down the weakest link here, I see that the first number has 3 decimal places. The second number has 3 decimal places, and the third number only has 2. So that's where I'm going to draw my line. So that's where I draw my line. I keep everything to the left. I throw away everything to the right. So the number that I would report is just simply negative 8.66. Calculations. So we don't always just multiply or just add. We often use multiple calculations in the same problem. So here you're just going to use your PEMDAS to get through the problem. And what you're going to do is at each step in the problem, you're going to consider significant figures. So you're going to multiply, figure out your sig figs, then take that number to the next step and add, for example, and then take that number to the next step and subtract. So you'll do sig figs at each step along the way. Here's another problem that I have put into the slideshow. So you can take a minute to try this problem. And then the answer is actually on the very next slide. So go ahead and pause this video, work through the problem, and I'll talk you through it on the next slide. To start this problem, we're going to start with the parentheses. So that's what PEMDAS tells us to do. So start here in the parentheses with the subtraction problem. With addition and subtraction, we're counting decimal places. So when I subtract these two numbers, I'll be limited to 2 decimal places. So that's the first thing we see here. So we subtracted those 2 numbers. We're going to cut it off at 2 decimal places. Right here. So this was the number our calculator spit out, but this is what we can keep according to our rules. The next step will be multiplication and division. So multiply, divide. When we multiply and divide, that's where we're talking about weakest link. So this guy has 4 sig figs. This one has 1, 2, 3, 4, 5, 6 sig figs. This one only has 2. So when I plug these numbers into my calculator, it's going to spit out a ridiculously large number. But we have to think about sig figs. We're limited to 2 significant figures. So I can only keep the 5 and the 2. Or rounding up, I can keep the 5 and the 3. So the number that I would report is 53. The important thing here is it has 2 significant digits. Hopefully that was helpful for you guys to hear. If you have any other questions, please reach out to me and practice, practice, practice. That's really the key to getting good at significant figures.